Hello everyone, my name is Alexis from Cordova Academy, and today I'll be discussing radical functions and showing you how you can graph these functions. The two functions that I'll be working with today are y equals the square root of x minus 3 with the minus 3 being outside of the square root sign, and y equals the square root of x minus 3 with the minus 3 being inside of the square root sign. And although these functions look very similar, when we graph them they are going to look slightly different. And this is due to the parameters. So let's learn a little bit more about parameters. The pairing equation of a square root function would be y equals a square root of x minus h plus k. And so this is the pairing equation for a square root, or as we call it, a radical function. And the first parameter that can be located here is a, and the a can show us or tell us the orientation of our parabola. So if it is going to be facing upwards or downwards, it can tell us if it is going to be vertically stretched, and lastly, if it is going to be vertically compressed. The next parameter is h, and the h can tell us if it is horizontally shifted, and k is if it is vertically shifted. Parameters are very important because just by locating the parameters in the equation of a function, we can easily create a rough image of what the graph is going to look like in our head without actually having to graph it out on paper. But in order to get a better understanding, we are actually going to graph two functions. The first function we are going to graph is y equals the square root of x minus 3. And the first step to graphing this is to create a table with three separate columns, the first column being x, the middle column being y equals the square root of x minus 3, and make sure that the minus 3 is outside the square root sign, and lastly, y. So the x column will represent the inputs, and the y column will represent the outputs. And so the numbers that I will be inputting are 0, 1, 2, 3, and 4. And as you can see, I did not choose any negative numbers as my inputs, because if I did, then I would be square rooting a negative number, and you cannot do this. And if I did, then the graph would look something like this. So the graph, if there were possibility of using negative numbers, would look something like this. And it would not pass the vertical line test, as you can see, because it would intersect this line more than once, and therefore it would not be a function, so we cannot input any negative numbers. So now, going back to these numbers that I have chosen, the numbers that you would get as your outputs for these numbers would be for 0, negative 3, for 1, negative 2, for 2, negative 1.59, for 3, negative 1.27, and lastly for 4, negative 1. And it is okay if you do get decimals. I just rounded it so it would be easier when I graphed it. And as you can see, these were the inputs that I input into this equation, and these were the outputs that I got. So now let's graph this function. So here I have set up my graph and transferred my table over with the different numbers so it is easier for me to look at while I'm graphing. So we're going to plot all the points. So the first one is 0, negative 3. 1, 2, 3, plot that one. Next 1, negative 2. Next 2, negative 1.59. 2, 1.59, roughly around there. Next 3, negative 1.27, roughly around there. And 4, negative 1. It's a little bit tough to plot those decimals, but it's alright. Next we're going to connect these with a curved line, these points, and add an arrow because we know this goes on forever. And we have just successfully graphed our first function, and now we are going to use the vertical line test to make sure that it is in fact a function. And yes, as you can see, it has passed the test, so it is a function. So now let's move on to graphing our second function. The second function that we are going to graph is y equals the square root of x minus 3, but in this case the minus 3 is inside of the square root sign. So we're going to use the same steps as before and create a table with the x and the y, and then the middle column being y equals square root of x minus 3. And now for the inputs that I'm going to be selecting, I'm going to be selecting 3, 4, 5, and 6. I have not selected any numbers that are less than 3 because if so, then the number that would be inputted into the square root sign would be negative, and like I stated previously, you cannot square root a negative number because then it would not be a function. So if I were to input these numbers, the outputs that I would get, so for 3 I would get 0, for 4 I would get 1, for 5 I would get 1.41, and lastly for 6 I would get 1.73. So these would be the outputs if I were to input these numbers into this equation. So now let's graph this function. So now I have set up my graph and transferred over my table with all the inputs and outputs, and now I'm going to plot the different points. So the first one being 3, 0, the next one being 4, 1, the next one being 5, 1.41, so roughly around there, and then lastly 6, 1.73, so roughly around there. And then I'm going to connect these points with a curved line because it is parabola, and then add the arrow at the end because I know that it continues to go on forever. So now let's conduct the vertical line test to make sure that it is a function. And as you can see, yes, it has passed the vertical line test and it is a function. And we have successfully graphed our second function. So now let's compare these two functions. So here we have the two graphs of the two functions that we just recently graphed. So as you can see, these two functions are very similar. Therefore, the graphs of these two functions are very similar, but they are not the same, and they should not be the same because they are two different equations. We know that they cannot be the same just by looking at the two different functions. As we can see in the first function, the k value is -3, so therefore the graph would be moved down -3, and that would be the y-intercept, which is, like I stated, -3. And in the second function, there was no k value, so because it does not intersect at the y-axis, and these two functions intersect the x-axis at different points, therefore they are different. The slight difference is that in the first function, 3 is being subtracted outside of the square root, but in the second function, 3 is being subtracted inside of the square root. This means that the two numbers that are being square rooted are different, therefore each input would have a different output. Because they have different outputs, there is no way that the two functions could have looked the same when graphed. We know that in the first function, because 3 is subtracted outside of the square root, it must be moved down 3 times. And in the second equation, because 3 is being subtracted inside of the square root, it must be moved over to the right 3 times due to the parameters. As you can see, parameters have a huge effect on how a graph looks and where it is located. And because the parameters were different in these two functions, the graphs would be different. So no, these two functions, when graphed, should not look the same because of the parameters and because they are, in fact, two different equations. This concludes my video. Everyone here at Cordova Academy, including me, is always here for assistance in math. Feel free to contact our homework hotline anytime at 310-123-4567 and or watch more of our videos here at CordovaAcademy.com.